Alright, so we are back. Problem 18. What is the area of the region enclosed by the graph of the equation x squared plus y squared is equal to the absolute value of x plus the absolute value of y? So, the most difficult part of knowing is that this is the equation, this includes the equation of a circle. And it's kind of difficult to really understand it, but looking at the answer choices gives you a little bit of hint that it's some sort of curve. This function, or not really function, but this equation graph probably has a curve of some sort since it includes pi, or some circular curve, or like a sine wave or something similar. It's probably going to include that. So we know that this can be rearranged into this. And it is very difficult to understand or to really see and foresee what you can see here, but the main hint is the answer choices. So moving on to here, this absolute value really makes the question a lot more, not difficult, but it makes it seem a lot more difficult, but really it's very simple if you know what to do with these. And what you should do with these absolute value are making cases. So reason being is because each absolute value gives you two cases to work with. So since there's two cases or two absolute values, then we're going to have four different cases for when x is negative and x is positive, and same goes for y. So we're going to list these C as cases. So now moving on, we can let this x be positive and y be positive. We can let this both x and y be negative. We can let x be positive and y be negative, and we can let x be negative and y be positive for the fourth case. So now moving on to here, we have the first case. We have x squared minus x plus y squared minus y is equal to 0. And reason because of this, if you have the absolute value of a positive number, it cancels out the absolute value sign, because you can't really have the absolute, or the absolute value of a positive number is just itself. However, you're going to have x squared plus y squared plus y, because if x is negative and y is negative, because the absolute value of a negative number is the negative of the negative number, and because of that it produces a positive sign. The absolute value always produces a positive sign, so the negative of a negative gives you a positive. So the negative of negative x gives you plus x. So now we just incorporate this over here. Let me incorporate this over here. And now we can complete the square and create the graph of these four circles. And you should learn how to complete the square in Algebra 1, I believe. So it shouldn't be too hard. So we're going to move on to here. And now we have four different equations of a circle, and that could really help us a lot. Wait. Oops, I did not mean to make this a positive. This is supposed to be a plus. Right? Y minus 1/2. So now we have these 4 different cases. And now, due to the equation of a circle, we know that this is centered at 1/2, 1/2. This is centered at -1/2, -1/2. Centered at 1/2, -1/2. This is centered at -1/2, 1/2. As you can see, it fits these restrictions perfectly. X is negative, Y is positive, X is positive, Y is negative. They're both negative and they're both positive. So now we can try and sketch it out. And notice that they all have the same radius squared. And notice that the equation of a circle is x minus a squared plus y minus b squared is equal to the radius squared, where a comma b is the center of a circle, if you didn't learn that yet. So notice that they all are kind of symmetrical. So we can have, let's say, 1/2, 1/2. And we don't know how this looks like, so let's pretend it looks like this. And then the same is going to go for, this is case 1. Not saying that this is the actual graph, but just to give you an idea. So this is going to be case 2. As you can see, it's all symmetric all around the whole graph because they all have the same radius. They all are centered at the same distance from the origin. So they're all symmetric across the x-axis, the y-axis. So in reality, you would just need to find one of these figures in order to, and multiply one of these figures by 4, and you will get the answer. So now we're going to create a new picture, and because we only need to find one of the area of one of them, we're going to use the first one just to simplify it. So I believe the first one was this. So that means the radius is equal to square root of 1/2, which is equal to root 2 over 2. So now we can draw kind of a graph. So let this be 1/2. This be -1/2. We know the center is going to be right here. So now, where do we find the radius? Root 2 over 2. If you try and draw it from here, it will not work because the distance from here is 1/2. Wait, did I write -1/2? Oops. Sorry for all these mistakes, but this is incorrect. That is not where the circle starts. So where does it start? It's somehow similar to 1/2. However, this is when the detection skills come very handy. So notice how these 2 points are equal. So that means we can create a little triangle right over here. Since these distances are equal, we have a 45, 45, 90 triangle. So we have S, 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 so we can let this be S, and we can let this be S, and this can be S root 2 due to the 45, 45, 90 equation. And therefore, if S is 1/2, then S root 2 is equal to root 2 over 2, which is the radius. So that is perfect. So now we know where the circle starts. Or not really where it starts, but something similar like that. So we can plot this point over here. And now we're going to need to find where else the distance is going to be root 2 over 2. So similarly, if you create something up here, this is for, say, 0.1. Then this distance right over here is 1/2. This distance still is 1/2. And then you can connect this right over here, and you have this point that fits over here. And similarly over here, this is also going to be all the way over here. And similarly, you have 1 over here. And this is not where it ends, because this point is 1/2. is going to extend past 1/2, because root 2 over 2 is larger than 1/2, since square root of 2 is larger than 1. It's going to somehow surpass it over here, and it's going to be over here. So now we have this little petal shown. And now we just have to find the area of this. However, we know that this is going to be a semicircle because this is 180 degrees. And still everywhere around here, the distance is going to be root 2 over 2. And since this is 180 degrees, this is a semicircle. And already here, we know that this is going to be a triangle as sketched out. So we know that the base and the height of this triangle are both 1. The reason is because the coordinate is 1 and the x-coordinate is 1, so it's going to be 1. So the area of the triangle is equal to 1/2. The area of the semicircle is equal to the radius squared, pi r squared over 2. And we know the radius is, or the radius squared is 1/2. So it's equal to pi times 1/2 over 2, which is equal to pi over 4. So now, this is supposed to be a semicircle, but now we have the area of the petal, because this looks like a petal, is equal to pi over 4 plus 1/2. So now the area of the graph is equal to 4 times the area of the petal, which is equal to, don't have enough space, which is equal to pi plus 2. And now we can select B as our answer.